Welcome to the session. Greeting of the day. In today's class, we are going to talk about the various applications of NDT. In various applications of NDT, we have looked over the important types in earlier classes. The topmost 7 to 8 types, such as this visual inspections, then liquid penetrant inspections, magnetic particles, eddy current, radiography, ultrasonic, acoustic emissions, and thermographics. The important some 8 methods which are largely used to do inspection, to repair, and then to rectify. So these are the important principles. Now we are going to see about the applications of these NDT techniques in various sectors. In previously we have covered few examples of NDT application in railways, NDT application in aerospace, NDT application in automobiles. So such examples we have seen. In continuous with that, we will see in today's session about NDT applications in offshore industries. Offshore is nothing but a seashore. It means where the oil, gas, petroleums are extracted from the ground levels and it is purified and then it is marketed. So one by one we will see. So we usually use the word seashore, offshore, onshore. So this is what these words. What are they? We use the name itself says it's off the shore. Shore is nothing but a beach or at the water level ends where our ground level is ending and the sea level is starting. There we call it a shore areas, a beach areas. Later after the beach, when we are going inside the sea levels, it is half the shore, half shore. So see half shore. So when we are going to work over on the offshore to extract these oils which are available, importantly we could have seen these petrols, diesels and all we are getting importing from the other Middle East countries, the Arab countries we are purchasing. So wherever the source is available, we are purchasing from them. They are marketing, and then from therefore the price hike of this petrol and diesel occurs in national wide. So this NDT technique is applicable there and is very useful to us to do inspection in offshore and in the extraction of the petroleum project platforms also. Methods are common. Liquid printer methods, same, it does the job. There is no difference. Radiography, same procedure process. Ultrasonic, same procedure process. We are talking here about the applications of this NDT in offshore. Application of NDT in petroleum industries. So it's nothing but offshore where we are taking the oils, where we are taking the gases and purifying, refining, and we are marketing. So this is the general procedure of extraction of gases, extraction of petrols, oils. So we are not going deep that side, but where is this NDT applicable there in these areas? A few things we have to see. Now we understand what the sea offshore. Offshore is the installation. See, offshore is the installation of structures and facilities. The structures and facilities to take the oil from the underwater ground level. The oils we have to extract out those. That is what the offshore is, the installation of structures and facilities in the marine environment, usually for the extraction of and production and transmission of oil gas from one country to the another country. Maybe to the shore also, from the offshore to shore, and in such a way in the shore the refining process will take place and later it will be marketed from one country to another country through again through the pipelines throughout the oceans. So therefore this all underwater process we have to do inspection there also because more corrosion involvement is there, quick cracking possibility it is there. So there also need joining. Pipe joining is a single pipe cannot travel 1,000 kilometers. We have to join every each and pipes. Right? We could have here this Reliance and all companies is taking oil from some other Middle East countries to somewhere to our countries or not. Okay. So each and maybe all countries. So likewise, we have the transportation is involved in underwater through these offshores, through these pipelines industries. So all these pipelines involved in welding. Then if it is involving of welding is there, definitely this entity also plays a main role to maintain quality. So you can see I have used the word offshore. There are two categories of installation of structures are there. This is the structure. You see, the left hand is the piled structure. The right hand is the concrete gravity structure. We have made a process of heavy extraction plant through concrete method. We have done extraction of oil plant or gas plant through this piled structures, towers we have made there in the middle of the sea. Somewhere it is going deeper and we are getting ready to bore there. A drilling operations we are going to do and we are going to take. As like our normally ground level putting a bore operations. Similar such patterns are done there, but it is in the sea, offshore. That is we are called as offshore. See, the heavy loaded structures are at the top of the piled structure or maybe the top of the concrete structure. So one by one, these are the various structures. The creating of structure itself is a heavy job. It is in service also. It is subject to the cold weather conditions, otherwise the ocean salty conditions. So it definitely corroding zone, heavily corroding zone. So we have to painting to be carefully done. The joint wherever we have done the welding process, frequent inspections to be there. Otherwise, light cracking may be breaks the one tower or one legs, collapse every session. Collapse the entire sections will be collapsed down. Therefore, it leads to the heavy accidents also. Well, if they are working employees, employment is there. So we should be very keen on that. See, the ND methods are extensively used in two major areas in offshore gas and petroleum projects, namely, so this two, fabrication and inspection of drilled platforms. That is what I told you in the previous slide. We want to drill to take those oils and gases, petroleums. See, for that fabrication we have to do for legs and piles and concrete structures and these tower structures and above all these shieldings, entire platform where we are working, which is over the sea. We understood this. So similarly, and then we have to do fabricate and we have to do the inspection similarly there only. So that is the point for drilling platform. So inspection of the flexible pipes. So these flexible pipes also to travel there at the bottom and therefore to do extractions. So this helps there. It means the main components of drilling platforms are number one is legs and piles are tubular sections are welded together. Previously we have seen images. The lower sections are larger in diameter and thicker than that of the upper sections. So because you see in the previous one, see in the previous images here the bottom sections are very thicker because we have to stand by loads are heavy at the bottoms only. The legs to be heavy and strengthened, then only we can able to support the large towers at the top. Maybe a structures or load carrying capacity ability to be there, which is to be at the bottom, is to be at the strength at the bottom to be there. Therefore, it is a large diameters and large thicknesses. Offshore is the installation of structures and facilities in marine environment, usually for extraction, production, and transmission of oil, gas resources to the shore for refining and marketing. The same definitions what we have seen in the previous slide. So this is what some of the few original images of this legs and concrete towers, which is where we are going to do drilling operations at the middle of the sea. You see leg piles, a large diameter, larger thickness. We are going up to the bottom of the ground level. Here the sea level. Here the sea level is there. So it is marked written also sea level. So up to then we have to go on nearly that height will be up to Burj Khalifa height. But a large tower is there. In the next slides, it is given. I have given there. Uh, Even though it is under the ground level, the total height of that it is equaling the largest building, Burj Khalifa. So it matches there the height. It's a data is given. After the data is there. It's true. See some of you here in this 2D sketches diagram. It is a traditional large steel jacket platform. Uh, Here we are seeing some various components name. As an example, as we are learning the names of the offshore platform components. So see various are there: mud, subsea pipelines, risers. This is the riser. One by one it is going upward. Risers, riser clamping systems. So here on we have to do joining. Joining operations we will do. Welding operations we will do. See at the centers, structures are very becoming very strong, and then the flexible pipes will go down, and then it will do a boring operations, and we will get the oils, and it will store and get back to the shore for refining process. So flare bottoms, all radio towers, because we are going getting inside the sea, we need communications, and also see helipad is the helipad also is available. So we have to get down here, do, and then we can go back. So such a heavy, large construction is there at the middle of the sea. How they are making this offshore tower plants? So transportation of jack to the same location, set up in one by one. See, set up jack at the bottom, and then drive batter piles one by one. They are increasing. See, one by one, one by one, one by one. They are increasing. So here also the third step, the fourth step, the skid piles, then the lower deck, and then the upper deck. So slowly it is increasing. Slowly it is increased up to the bottom. See, up to here. So slowly their plant is developed, where such many more joints welding involved. Therefore, many more NDT inspection service also mandated. See, it is the original image of bulk winkle oil platform shell over 400-meter long. 400-meter long, a large setup is there. See, this much large setup. Even there are using more numbers of ships to take over to the plant where this is to be installed. So how construction is there? See, usually this platform takes a more number of joints. Then obviously inspection. Some few images is how the total sea setup where the platforms are field locations. So here one bore, here one bore, here one bore, here one bore. There are multiple bores they are making, and they are taking the oils. So here this is what this is the top surface you are looking, which is straightened to the ground level, but at the bottom they are going deeper up to the Burj Khalifa height. The data says the world largest half-shore platforms. I want to show some examples of few here. A Brooklyn platform, Russia's far east. The Burkett platform is expected to produce 12,000 tons of oil daily. That much large boring ability is there, are about 4.5 million tons annually. So see the setup. This is the concrete setup, not a piled setup. This is the concrete setup. This is how they are loaded inside, and they are started to bore. Here also helipad. See, this is the helipad. I think it is visible. And then they are taking maybe refining process, and then they can transport from one country to the another one, or maybe taken to the shore and they can do. So this is one more. A Predator deepest floating oil, a deepest floating oil platform in the world at the water depth of 2,450 meters. They went inside 250, 2,450 meters. They went inside in location of Gulf of Mexico. So more than that of Burj Khalifa. Next one, a Petronas oil platform is one of the largest also, located in the Gulf of Mexico. See how the platforms are there, a pile structure here. There we have seen the previous slide is a concrete structure. The structures are examined by, now we are coming into the types of methods we are using for maybe the radiography, maybe the ultrasonic, or maybe the liquid printer and other methods also. So mostly radiography, ultrasonics are used maximum. Structures are examined by gamma radiography has maybe the longitudinal or maybe the circumferential welds, whatever it is. So see weld involvement is here. Cobalt 60 is used as a source of penetrating radiations because it is having greater life factor, therefore we are using that. Similarly, this is about radiography. Similarly, ultrasonic methods are also used to assess various weld joints. Yes, maybe the ultrasonic method or maybe the radiography method, whatever we are expecting, whatever the possibility is there, we can able to do. However, the operator who performs the ultrasonic test must be approved as per the American Pipeline Guidelines API. API guidelines for their qualification. So here welder need certified scheme of welder inspection program CSUP for to inspect the welding. At the same time, non-destructive testing level 3 is there, so that we need to do inspections. NDT level 2 is there, those people will become technicians, operator of the ultrasonic machine, radiographic machine. They set the film, take the operate the machines of gamma radiography, and then they take the film and they will submit it to the higher authority of who have certificate in the level 3 level, NDT level 3. NDT level 2 become technicians, NDT level 3 become the inspector. At the same time, certified welding inspector scheme CSIP, who had certificate of CSIP 3.1 will become a welding inspector to inspect specifically the weldings. And then if the ultrasonic expansion to be there, you see it is given as API guidelines. Okay, pipeline industries. So likewise, if you wanted to work in industrial sectors, we need certificates. So certificates only it's authorized one to which makes you to sign. Some other things are learning will not. Well, learning gives you experience and trial and error methods, but certificates only valid to make you sign. Initially, efforts are made to correlate radiographic and ultrasonic indications to establish the confidence level. So we can able to use both the ultrasonic method and also this radiography, and we can able to compare and we'll get some confidence level both what the results they are giving, where is the defect are available, what is the discontinuity, what is the range, whether it is permitted not permitted. These things all compare and we'll get some confidence because it is seashore. Heavily it is going to affect and heavily it is going to corrode also. So there are life threat is there, life threat zone it is. We have to save life, at the same time cost, at the same time the building structures, all things. At the same time we should earn money also by extracting, by drilling all those work. It means work to be complete effectively. Ultrasonic test methods includes, as like gamma radiography we have seen the previous line here, for ultrasonic it may be the pulse echo methods or maybe the time of flight techniques. There we are using maybe the A scan, B scan or C scan methods of the data presentations are used to indicate the conditions of the entire volume of the weld zones. The magnetic particles, we have completed radiography, we have completed ultrasonic, and we are trying to do here the magnetic particle test also. And maybe the visual examination also can be carried out to check the surface and also this subsurface inspections. So accordingly, it will change. If it is surface, we can go for visual and liquid penetrant or magnetic particle. If it is subsurface, we can go for this the ultrasonic and radiography inspections. So it depends. Even the magnetic particle can do near subsurface zones. We have to keep in mind. So some of the images I would like to show you where this ultrasonic inspections are done. You see here they have a setups, and then the employees are over the sea, over the platform and they are working effectively. They are the inspectors. See how they are doing inspections with their dirty shirts effectively. Inspector does not mean we are in the white collar job. It is somehow a rough job. See, they have the setup and they are doing inspection. So this image shows you here we are using a flexible pipe. Next category I am coming to talk about the flexible pipe. It means we have talked about the platform, the structure where it is installed, welded, and it is ready. And then we have to take a drilling pipe down to the ground where the oil is coming out. That we have to take. It is not a straight line. It's not a straight pipe. We are moving the locations here and there at a certain zones. It will be available. So we have to bore there, 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 there. So at that time it is a flexible pipe. We have to move here and there, and it is to be stored there. Maybe in the ship we can bring under that large tanker. We can fill like submarines. Okay, so that is to be designed. So we are using there for durability we need and strength we need for those pipes. So that is also a composite material we are using, and that is also to be subject to inspection. You see, that is why some colored image designed to have a strength durability associated with the rigid steel pipes and flexible systems. Flexible are often the only solution for risers in a dynamic environment. So this is how it looks. A 2D line sketch it is given there. See, we have a structure here. It means a welded platform structure, a big large one to do helipads and structures to refining setups, offshore large setups is there. From there, where boring zone is different at the seabed zone. So we have to have a flexible pipe there to go there. So that is what it is. It is going here. See, from here to we are going somewhere at some point, and we are doing a flexible pipes. Flexible pipes are going to fluctuate. Strength is needed, rigidity is needed, resistance. So this all combined factors are needed. Therefore, you see, I have given a small understanding of this materials related. What is a pipe material? We are a little bit non-NDT techniques we are talking. So here it is a function of this outer layer. There are more number of layers. There is left side image. You see, left side is showing pipe at outermost cover. With respect to that, there are multiple layers are there for its multiple functions. So from one by one, I will read it here. External fluid barrier, a tensile strength layer, anti-wearing layer, tensile strength layer again one more giving, anti-wear layer one more we are giving, a double layers we are giving and protecting, and hoop strength layer, then finally one more a fluid barrier, and then last we have a collapsible resistant layer. So all these are made up of again polymer, carbon steels, and then the stainless steels we are using here. It is a flexible. That is what it is named as flexible pipes. So this is how we are. We need its functions to protect from the surrounding water corrosions. And we are using multiple protecting layers here. Unbonded flexible pipes. Unbonded flexible pipes consist of concentric layers of metallic wires, tapes, extruded polymers designed to form a structure that address the specific environmental requirements, nothing but a corrosion environment. Because water keep on touching, that pipe is going to 24/7, it is to be in contact with that water. Definitely it is a corrosion. It will erode those pipes. So it's to be very corrosion resistant material first to be installed. Maybe as like it is given polymer, maybe the stainless steel materials we can use, and multiple protection layers, barriers. So now the regarding applications, it should be a static dynamic applications, maybe flow lines are there for static applications, a smooth boring, maybe the water injections. If it is a rough boring, maybe the oil and gas conditions, because oil itself it is one of the fluid which contains some chemicals. So it is also wanted to go through the pipes, not like water. So even water do come corrosion. So gas, a toxic gas may be there. It is also subjected to uh, damage these pipes. So all these things are there. Regarding H2S pressure, speed service and source service are there with H2S and without H2S. Hydrogen sulfide. See next one. A key design, therefore we are planning to do some key designs of this flexible pipes. Some points I have given here. So it should touch the ground down point. It may be the ground, may be the sand, therefore it may be the abrasions will be there, and then it floated over there. Somewhere we will have some bores somewhere at some point. Okay, so from that point it is pipes to be floated inside the water, and then it slowly it comes up to reach this station, a structured station. Right? Therefore, some pipe to be made with a high quality. So it means there the joining will be there. Large pipe, a single pipe in as like what we are seeing here, a rolled pipe. Also, the complicated, complex designed quality pipes will be there, which is to be inside the water conditions. So these are the various specification is given here. Flexible pipes are used for production, a gas lift, a water injections, any applications. Maybe the gas, maybe the oils, or maybe the water injections, or petroleum conditions. These pipes are made up of a composite, a multi-layered structures, a multi-layered structures. Now only we have seen the previous one. A multi-layered structures, and then are critical components of offshore exploration activities. These pipe links and the offshore platforms and the well-headed on the seabed are subjected to corrosion, erosion and fatigues. Yes, true. So it is to be subjected to the seabed at a level, ground level it is going to fall down and it is to be flattened and then it is going to do its job. That is why it's subjected to corrosion, it's subjected to erosion, it's subjected to fatigue too. Indeed, NDT inspections on this pipe includes maybe the visual, maybe the eddy current, maybe the X-ray, maybe the flux leakages, maybe the ultrasonic too. So see, Maxim we have covered all these 7 to 8 important techniques repeatedly again and again for all the applications. So, but we are seeing what are the content, how it is utilized there. A considerable amount of a development work is going into the sea area to develop adequate and cost effective NDT technique which does its job in the sea zone inside the underwater conditions. Okay, maybe in service and it can do the repairing operations. Not only replacement, repairing issue is one of the effective method. In so far as the NDT is a deep sea installation is concerned, what we have seen in the last 6 to 7 slides, it is a deep sea installation structure, we understand. Therefore, we can able to adopt some robot based inspection also here. In the inspection, we can able to try with a robot based inspection. Robot based systems are used for inspections and maintenance too. The usual problems that one encounters are, if the robot is moving for the inspection, it is somehow it is find difficulty to find what is crack and what is corrosion. So we have to feed to the robot. This is what it looks like this. So we have to program it properly, and we have to give trainings to the robots under the water components. Advanced artificial techniques have also developed to classify this corrosion and cracks. Yes, AI methods are there, artificial intelligence. So this is how we understand these methods. As of now, the summary here. As of now, we have seen the applications of NDT in this gas, oil, and petroleum platform industries. Maybe mostly we could have seen in the Middle East parts, because they only have much more oil-based zones. It is more type of job offers are also there in those Middle East companies like Saudi, Qatar, Dubai, okay, UAE, Kuwait. So these are all we have seen about these applications. In the next classes, we have to see about the applications of NDT in coal mining. So that is one more area. Coal mining is there. This coal mining. So that we have to cover industries application of NDT in the coal mining part. The remaining part of the subjects we'll see you in the next session. Thank you.